Hello dear students, welcome back in our video lecture series on subject Structural Analysis 1. So as you know, we have started lecture series on Analysis 1. So in today's session we will start lectures on module 3, that is in our syllabus it's fixed beam. So in today's first lecture of module 3 we are going to discuss about statically indeterminate beams. The objective of this lecture is that after the completion of this lecture you would be able to understand statically indeterminate structures, understand difference between statically determinate and indeterminate structures, and also you can know about propped cantilever and what is its effect. So let's start our discussion with introduction. So what will happen when a cantilever beam is subjected to transverse loads supported by additional support? What will happen? There is a cantilever. What is my cantilever first? Yes, in cantilever beam one end is fixed and other is free. So in such case of cantilever which is subjected to transverse loading or downward loading, maybe in the form of UDL or point load, there will be maximum deflection at the free end and bending will be more as compared to simple beam, and which generates bending movement in the beam or fixed end movements at the support. So if we add additional support at the free end, what will happen? This beam will become stable, or stability of structure will increase, and also the maximum bending moment at one end will be reduced. Okay, so let's define what is mean by statically determinate beams. As you know, the beams which can be analyzed by the conditions of static equilibrium. Now which are the static equilibrium equations? You know, yes, summation of all horizontal forces will be 0, summation of all vertical forces will be 0, and summation of moment will be 0 in any beam or structure, or any structure which satisfies these equations and can be analyzed by using only these three static equilibrium equations, then such beam is termed as or defined as statically determinate beams. What about indeterminate? So let us first tell me the examples of the statically determinate beams. Yes, cantilever beams, simply supported beams, and overhanging beams. So these beams can be easily analyzed by using these simple three equilibrium equations or static equilibrium equations, or we can say these beams are statically determinate beams. What about statically indeterminate beams? Suppose, as we know, a cantilever is a statically determinate. So now we are saying it is statically determined. Why? Because as we know, in cantilever one end is fixed and other is free. In case of cantilever, the support reactions or reactions will be upward reaction at the end. You can see in the diagram there is a cantilever, one end is fixed, other free. At the support there is upward reaction and movement. These are the only two reactions in case of cantilever. Okay, so an equation of equilibrium again, summation of vertical forces, because it is subject to assume that transverse loading will be 0, and summation of movement that is subjected to bending movement at the fixed end, and summation of movement will be equals to 0. By using these two equations we can analyze this beam. So it's a statically determined. What will happen if we add a support at the free end or free and reduce a prop? Then it will result in extra reactions. अगर यहाँ पे extra support add करेंगे at the free end, if you add a support which is termed as prop, then it will create or will result in the extra reactions. Now such type of beam cannot be easily analyzed by using these three static equilibrium equations, and the calculation of this reaction involves another extra equations. So it will become stable but indeterminate. So prop cantilever is a single degree indeterminate structure. Now why this single degree? From where this single degree indeterminate come? Now you can see here, in propped cantilever reactions are two support reactions and one moment at the fixed end. There are three reactions, and equilibrium equations are only two in such case of beam, that is vertical forces will be equals to 0, so summation of moment will be equals to 0. As equation or equilibrium equations are 2 for this case and reactions are 3, which are more than 1 than the equations available. Hence 3 minus 2 will become 1. Hence the prop cantilever is a single degree indeterminate beam. Like this we can find the degree of indeterminacy of the beam or structure. Now to find this extra reaction, these three static equilibrium equations are insufficient. Just we have discussed. In diagram 1 you can see there is a cantilever beam where one end A is fixed, span is L, and which is subjected to loading in the form of UDL. In second diagram you can see there is figure, one end is fixed, that is A support, and other end, that is at the free end, there is extra support is introduced, that is at B, or which is prop. So in second diagram you can see cantilever with prop reactions. Now what is mean by this statically indeterminate? Now you can understand by this example of prop cantilever what is mean by this indeterminate structure. Yes, it is the beam which cannot be analyzed by the conditions of static equilibrium alone, or the equations of these equilibrium are, as we know, summation of h equals to 0, summation of v equals to 0, summation of m equals to 0. By using this equation, if any beam or structure cannot be analyzed, then such beam or structure is termed as statically indeterminate beam or structure. Which are the examples now? Yes, just discuss prop cantilever. Again, fixed beam and continuous beam also comes under the statically indeterminate beams, which we will discuss later on in this series. What is mean by this degree of static indeterminacy? Just we have gone through degree of indeterminacy. So it can be defined as the number of unknown forces in excess of the equation of the static equilibrium. Just we have seen single degree of freedom or single degree indeterminacy for a cantilever beam. How? The number of forces are 3 and number of equations are 2. 3 minus 2 will be 1, and 1 will be the degree of static indeterminacy for the prop cantilever. So likewise you can define it. Now let's continue discussion on propped cantilever. Now in case of prop cantilever, just we discussed some supports other than existing ones may have to be provided to avoid excessive deflection. What will happen after adding the extra support at the free end? The excessive deflection will be avoided in somewhat manner, and this additional support is known as prop. Now you can understand what is meant by prop. I hope you can define this prop cantilever and what is meant by this prop support. Now tell me why prop is provided, or what will be the action after the application of prop. Yes, it reduces deflection, maximum bending moment, and as well as shear force. Now provision of this prop makes this structure as indeterminate. Okay, as we know, cantilever is a determinate structure. If we add a prop support, and it makes this structure indeterminate. So let's summarize what we have discussed in today's session. So in today's session we have discussed what is prop cantilever. What is prop cantilever? Yes, when a cantilever beam subjected to extra support at the free end, then it is prop cantilever. What will happen when additional support is provided? Yes, when additional support is provided, it reduces the bending moment and deflection as well as shear force in the beam. So based on these points, let's have a quiz or some MCQ questions. Hope you can answer. A prop is provided primarily to, and options are to reduce deflection, option B to reduce bending moment, option C to reduce shear force, and option D is all of the above. Now can you answer? Prop is provided primarily to. Yes, it reduces deflection, bending moment as well as shear force. Hence correct option will be all of the above. Here there is a second question. Select a statically indeterminate beam. You have to select or choose statically indeterminate beam from the following options. And options are cantilever beam, B simply supported beam, C prop cantilever, and D overhanging beam. Which one is the statically indeterminate beam? Yes, again you are right. Option C is the correct one. That is prop cantilever is a statically indeterminate beams. And remaining three options are the examples of determinate beams. So based on these points, in examinations it may ask some of the questions. So these are the frequently asked questions on your screen. You may note it down. What is indeterminacy? Yes, you can define. What is point of contraflexure? So this point of contraflexure we have not discussed in this session, but it is already have been discussed in strength of material, shear force and bending moment chapter. So you can answer this also, or this question may ask based on the topic we have just discussed. So today we will stop here. In next session we will discuss about analysis of prop cantilever.